Hi folks, today we are adding another panel to our collection. This panel uses a PT6312BLQ as the VFD driver. It also includes a HOLTEK microcontroller, model HT48R05A. Judging by the symbols present on the display, this panel most likely belonged to a CD or DVD player. Unfortunately, the original brand and model are unknown. So, if anyone recognizes this panel, please leave the information in the comments. Since we have already covered the PT6312 several times here on the channel, today we will focus mainly on the panel itself. The presence of the microcontroller limits the flexibility of the panel, because ideally we would need to modify the firmware stored inside the microcontroller. Even so, we can still bring the panel back to life and make use of several of its simpler functions. In fact, the two integrated circuits can even be powered separately. That means we can choose not to power the HT48R05A and instead use only the PT6312. First of all, it is important to mention that the standby button is connected to pin 15 of the HOLTEK microcontroller. This allows the microcontroller to control the red and green bicolor LED present on the panel. When the button is pressed, the LED changes from red to green. At the same time, the signal on the CTL pin changes from a high state to a low state. The bicolor LED itself is controlled through pins 1 and 2 of the HOLTEK, and pin 3 receives the signal coming from the infrared receiver. To reuse the panel, we implemented an event trigger on pin 3 of the Arduino. This trigger activates whenever the signal present on the CTL pin changes state. It is important to note that pin 2 of the Arduino already has a trigger assigned in the code, used for the segment identification process. The 5 buttons located on the right side of the panel are read directly by the PT6312BLQ. Their functions can be assigned inside the read buttons function. In this example, we assign the buttons to configure the clock created for the Arduino, but these functions can easily be changed. As is common with this family of VFD drivers, communication uses the standard serial interface lines: data in, clock, and strobe. And of course, we must never forget the importance of a common ground reference between the panel and the Arduino. Now, let us look at the power supply method. Since the PT6312 uses negative voltages for the grids and segments, we require 3 completely independent power supplies. These are plus 5 volts for the logic section, another plus 5 volts for the filament, and finally, a minus 24 volt supply. To generate these voltages, we use 2 DC to DC converters. One converter generates 5 volts to 5 volts. The second converter generates 5 volts to 24 volts. The main 5 volt supply powers both converters and also feeds our H-bridge circuit, which is responsible for generating the filament voltage. We already used this same H-bridge approach in previous examples to demonstrate how to reduce the shadowing effect that appears when the filament is powered with direct current. However, in this particular case, we could also easily replace the H-bridge with a DC to DC converter set to 3.3 volts, since the filament current is only around 100 milliamps. Now regarding the buttons. The first button on the left side of the group of 5 increases the hours. The second button decreases the hours. The third button increases the minutes. And the fourth button decreases the minutes. Finally, the fifth button performs a complete reset of the clock. After all of this is implemented, the panel becomes fully operational, and I have to admit, the brightness and visual quality of this display are truly impressive.